4.7 Quadratic Formula. This will work for all quadratic equations, and I recommend you get really efficient with this because this will help you with any real or non-real solutions. So any of those imaginary numbers, it'll work for any of those decimal numbers in simplest radical form. This is the way you want to work. If you see that all your answers on a standardized test is in like radical form or non-real answers, this is the way you want to solve it, by using the quadratic formula. So be really efficient with this, and they give you the formula on the standardized test, so you don't have to memorize it, though it's really easy to memorize. You may need it for SAT or ACT, but it's something that's easy to use. You just plug into a formula. Okay, so let's get started. All right, so the quadratic formula will always solve any quadratic with real or non-real solutions. If factoring was problematic for you before, you can use this formula, but I'm telling you, factoring we're going to use the rest of the year, and most of the problems that where we're using the factoring will be very straightforward. So you do need to know the factoring, and because it takes less time in many of the situations that you're going to use it. But for, like I said, if you have any answer choices on a standardized test that are decimal, simple radical form, or imaginary or non-real answers, this is the way you want to go. Alright, so use the quadratic formula. The equation must be in standard form, which we talked about, as you should know by now. Ax squared plus bx plus c equals 0, standard form. The quadratic formula itself is x equals, so this is going to give you a solution or a root or a an x-intercept where it's going to cross the x-axis. Okay, that's what's an x equals problem. But the formula is x is equal to opposite of b, whatever b is. Okay, coming from right here, opposite of b plus or minus. So there's the two answers that you're going to have. The square root of b squared minus 4 times a times c, all that divided by 2a. So all you're going to do is be plugging in right here, here, these two places, and right here, and solving this. Now, you need to take it slow until you get really good at this, because you can't just plug it all in into your calculator one shot. It won't work. All right? If you'll notice, the quadratic formula is made up of two parts. Okay? We've used this before when we were talking about vertex form. This part right here. Okay, this part alone makes up opposite of b over 2a, which is your axis of symmetry formula. Okay, so you already know part of this formula already. And then underneath the radical, this part right here, the b squared minus 4ac, that is called the discriminant. Okay, the discriminant, you must know what that word is and what it does. Okay, the discriminant is just the b squared, not the square root of it, just b squared minus 4ac. And that's going to determine the number of roots and the types of solutions that you're going to have, the number of solutions and types of solutions that you'll have, whether they're real or non-real or just one, what it's doing. That'll give you all that information just by plugging in right here. So oftentimes you can figure out what's going on with the parabola by what's going on with the discriminant. Okay, so we'll be practicing using just the discriminant. All right, so if you have a discriminant and you plug in your numbers right through here, if it produces a positive number, so when you finish all this and you'll get a number, if it's a positive number, that means it has two real solutions. Okay? If it's equals to 0, it's only one real solution. What that ends up being is a double root. Okay? Double root, where it just goes down and touches the axis and whoops, not like that, hold on, went too far. Goes down and touches the axis and bounces up. That is a double root right there. okay? That would be like an x plus 2 times x plus 2 thing. That's a double root. All right, and that's what it looks like. So if it comes out to be 0 when you put in your discriminant, that's what it's going to give you, one real solution, which is this kind of situation right here. And if you plug it in and you get a negative number, that means you're going to have two non-real or imaginary solutions. Those are the kind that just kind of hang around up in the air, never cross the axis. Those are two non-real solutions. All right, so we're going to determine the type and the number of solutions using the discriminant for these. First, I recommend that you always do A, B, and C for everything that you do. Go ahead and just set it up, A, B, C, and then say what your parts are. Remember, A goes with your quadratic term, your B goes with your linear term, and your C goes with your constant. So our A in this one is 2, our B is 7, and then our C is 3. So if I plug that into my formula, b squared minus 4ac, b squared, I'm just going to use parentheses everywhere I plug in. So probably a really good habit to get into. Minus 4 times, what's my A? 2, and my C, which is 3. And then if you type this just like you see it with these parentheses in your calculator, you'll get the right answer. That makes 49 minus, negative 4 times 2 is negative 8. Negative 8 times 3 is a negative 24. All right, so when you subtract these, you're going to get 25. And 25 is a positive number, which means it's going to have two real solutions. 2 meaning the number, and the type is both are real. Okay? So this is what the discriminant does. It comes up with a number to tell you it's going to be two real solutions. It doesn't tell you until you do the entire quadratic formula what those solutions are. It just will tell you what kind they're going to be and how many you're going to have. All right, let's do this one. So my A is going to be 3. My B is going to be negative 1. And my C is going to be 14. All right, plugging into my formula, that is b squared, negative 1 squared minus, whoa, I forgot my 4. 4 times A times C. All right, so this is negative 1 squared, which is 1. Negative 4 times 3 is negative 12. And negative 12 times 14 make, it's going to be a negative something. Let's see, negative 12 times 14 is a negative 168. This is negative 168. So when you finish this, 1 minus 168 is going to be a negative 167. All right, so that's a negative number. That tells me I'm going to have two non-real solutions. Don't know what they are yet until we completely finish, but that tells me what they're going to look like. All right, and then let's do this one. This one is going to be A, B, C. A is 1, B is negative 12, C is 36. So plugging that in, it's going to be B squared, negative 12 squared minus 4 times AC. A is 1, C is 36. All right, so negative 12 squared makes 144 minus, and then negative 4 times 1 is negative 4. Negative 4 times 36 is 144, which makes 0. So this one is just going to give me one real solution. I don't know what it is yet, but I know that parabola is just going to come up here like this one and bounce off just like that. Okay? One real solution. So that's what we do with the discriminant to determine the type and number of solutions. So when it asks you for that, they're asking you to do the discriminant. It's not necessarily going to straight up say, using the discriminant. You must know that that's what you need to use. Okay? All right. Now, change the page. All right. Using the quadratic formula, when we do these equations, you got to make sure that the equation is in standard form. Determine what A, B, and C are. So that's what we've been doing. We're going to substitute into the formula those A, B, and C's, simplify, and solve. Okay, so let's get started with this one. I'm going to say A is equal to 2, B is equal to 2, and C is equal to negative 1. Okay, now my quadratic formula is opposite of B plus or minus the square root of B squared minus 4AC all divided by 2 times A. Okay? That's what X is equal to. These will give you the intercepts or the solutions or the roots. That's all it gives you. Alright, so when I do that, I'm going to take this, and it says opposite of B. Okay, negative B means opposite of B. What's my B in this case is 2. So I'm going to have opposite of B is negative 2 plus or minus square root of B squared. And again, you'll see me using parentheses where I'll plug in A, C. Alright, that's all divided by 2 times my A. Alright, now, I recommend that you do all this underneath the radical first if you're going to use your calculator. Okay, so that's going to be minus 2 plus or minus the square root of something. Alright, so if I put in 2 squared minus 4 times 2 times a negative 1, I'm going to get 12. So that is the square root of 12 all over 2 times 2 is 4. Okay? Alright, from here we need to simplify because the square root of 12 is not simplified. It's not in simplest radical form. And we have already learned that that is something that you just can't just leave. So remember when you do this simple radical form, you break down 12. So that's 2 and 6 and 2 and 3. So that makes 2 square roots of 3. So this becomes negative 2 plus or minus 2 square roots of 3 all over 4. Well, guess what? That's still not simplified because all these outside numbers are divisible by 2. So this becomes negative 2 divided by 2 is negative 1 plus or minus 2 divided by 2 is 1 square root of 3. And 4 divided by 2 is 2. Now, if you need to put that 1 right here in front of the square root of 3, that's fine. But if not, this is what you'll see. These are the answers that you'll see in a multiple choice type test. Okay? So, if you had to find the exact thing, you would put in your calculator negative 1 plus the square root of 3, hit enter, and then divide by 2. Or negative 1 minus the square root of 3, hit enter, and divide by 2. Okay, you have to do all the top, hit enter, and then divide by 2. One at a time because you do not have a plus minus button on your calculator. Right? Alright, so this one is A is 3, B is negative 4, and C is 3. Alright, notice we're not having to do anything special because that quadratic term is bigger than 1. We don't have to do anything special when we're doing the quadratic formula. So this may be the best thing ever for most of you. And that's fine if that's what you want to do. Use it. That's what it's there for. Alright, so we do the opposite of B. Well, the opposite of negative 4 is 4. plus or minus the square root of b squared, negative 4 squared minus 4 times a times c, all that, divided by 2 times a, which is 3. Right? Again, put all this stuff under the radical into your calculator first. So that's going to be 4 plus or minus the square root of, let's see what that is. It's going to be 16 minus 4 times 3 times 3. Negative 20. So this is going to be negative 20 all over 2 times 3, which is 6. Alright, and you see this, you know it's not simplified, and it's because it's an even index, you know that that negative becomes I. So we have to simplify that. Alright, so I'm going to go down here, 4 plus or minus, I'm going to take that negative out as an I first. Put it right there. Now we need to break down 20. So that's going to be, because you have your I right there, 2 and 10, 2 and 5. So that's going to be 2 square roots of 5, 2 square root of 5, all over 6. Then you look, these three numbers on the outside are divisible by 2, so you need to divide everything by 2. So that's going to be 4 divided by 2 is 2, plus or minus. 2 divided by 2 is 1, so you can put 1 or you just put your I. Square root of 5 cannot be simplified because it's under the radical. And then 6 divided by 2, which is 3. So this is our final answer. So when you see answers that look like this in a multiple choice situation, this is the type of thing you need to use. You need to use quadratic formula, okay? If it's not factorable, or maybe the coefficient's bigger than 1, you don't like those, use this. You can use this anytime you want, but anytime you see answer choices look like this, you definitely want to go this route. I think it's much, much easier. And all you're doing is plugging it in and just taking the pieces at a time so you don't get a big mistake when you're doing your calculations with your calculator. Okay? All right. And that's all. We will practice a lot of this in class. But it's very, very simple and straightforward. You know, you do have to break down your radicals, something we've already learned. You have to take care of your negatives under the radicals, which is the complex numbers, which we've already learned. So there's a lot of different rules that you have to remember when you're doing all these things. And that you'll find true with all of Algebra 2 is constantly remembering to do the rules that we've learned in the past and simplifying, simplifying, simplifying. So we will practice this. Come see me if you have any questions, and I'll see you in class.